Hello guys, welcome back to Maths on African Motives. In this platform, we are going to focus on the derivatives, that is differentiation, from the question paper of April 2020 for Mathematics N5. We are given questions on question number 2, where we've got derivatives throughout, and as you can see here, that's a total of 23 marks. So I shall quickly rush through the questions so that we can see how we are supposed to simplify or determine the derivatives that we are given in this case. So the first part on 2.1, we are given to derive a formula to determine dy dx if y is equivalent to arc cot x. Okay, so this is arc cot x. Okay, so how are you going to find this derivative, or the formula of finding the derivative of such a function? Okay, so if you are given arc cot, so this was actually written as arc cot x like this. So this arc cot simply means the same as writing as y is equivalent to arc cot x like this. Cot to the exponent of -1, that's arc cot. So how are you going to find the derivative of this function of y with respect to x? We can't determine this derivative directly as we can see here. So remember that for you to find the value of x, we can actually find the value of x by writing this cot here. So actually, to remove this arc cot here, we just introduce the inverse, which is the cot both sides. So the moment we introduce cot both sides, that means we are going to remain here with the cot of y, which is equivalent to x. So the cot and the arc cot, these two, is actually to remove that arc cot. So which means you're going to remain with x. So x is equivalent to cot of y. So that is the simplification that you are going to apply. So if this is the simplification that we have, as we can see, we are now left with x and y in this case. This is x and the other part is a y. So to find the derivative, what you're going to do is you're going to differentiate with respect to x. So here you find the derivative with respect to x. Here you also find the derivative with respect to x. But as we can see, on the left-hand side, this is cot y. We do not have x. So how do you differentiate that? You are now back to your implicit function where you differentiate it with respect to y. So with respect to y, remember cot gives us negative cos x squared. So it is going to be negative cos x squared y like that. But the answer that you're going to have, you multiply with dy dx. Take note, it was a derivative with respect to y, but it is supposed to be with respect to x. So your answer, you multiply by dy dx, okay, which is equivalent to the derivative with respect to x of x. X is just, we've got x here, so it's going to be 1. Okay, just as we know, guys, if you're given y is equal to ax, dy dx is going to be a. Just take the constant. So the constant on x here is 1. So that's what you're going to have at the end. So this is what we have. We can find our dy. Remember, to differentiate is to find dy dx. So in order for you here to remain with dy dx, definitely you have to divide both sides by negative cos x squared, because it's multiplying here. So this is going to be -1 over cosec squared of y if you divide both sides. So that's the answer that we are having. But this answer now, it's supposed to be with respect to x. And our answer is containing y here, which is supposed to be x. So how are we going to rewrite our answer in terms of x, not in terms of y? We are going back to this consideration that we had previously here. Remember that we are given, we need a part which has got cosec. Okay, we just have this one for cot. Okay, so let's simplify first and see if we can have this identity with cot, because we have got a part that is got cot here. All right, where do we have cot? From our identities, we are given this identity from one of the Pythagorean identities, 1 plus cot squared. Okay, if it is cot is going to give us a sec or a cosec on the other side. So this is cosec squared y like that. If it is tan, if it was like this, 1 plus tan squared y, then it was going to be sec squared y. So here we're dealing with a cot. So from this part that we have, can we actually make cosec, already cosec squared is the sub because it's 1 cosec squared y is equivalent to this. So that means in place of cosec squared y, we are going to substitute with 1 plus cot squared. Okay, because we've got something that has to do with cot previously there. All right, so this is what you're going to do in place of our cosec squared. Like I said, we are going to substitute back. So it's going to be dy dx is equivalent to -1 over cosec squared y, which is in this case, cosec squared is same as 1 plus 40 squared y. So it's going to be 1 plus 40 squared y. So this is still in terms of y, but why are we writing like this? We want to achieve a condition that is got x and cot. And we have this previously here when before we had to find the derivative, this was cot y here is equal to x. So from that part that we had, if truly that cot y is equal to x, but on this part, we must have cot squared. So what is going to happen for us to have cot squared? It simply means we are going to square both sides. So if I square here, I have to square here. Remember, this is an equation. What you do on the left-hand side, do it also on the right-hand side. So that's going to be cot squared y is equal to x squared. So wherever there is cot squared y like this, we are going to substitute with x squared. So that means our answer in this case for dy dx can be written like this. Dy dx is equivalent to -1 over 1 plus cot squared y, of which cot squared y is equal to x squared. So this is going to be 1 plus x squared. So as you can see here, we are having a simplified answer with respect to x, but here it was in terms of y. So all this process is for us to obtain something that has got x on the final answer, not y on the final answer. So that was the consideration from that part. Okay, so on 2.1, that was actually the derived the formula. Then 2.2, determine dy dx of each of the following. Okay, in each of the following cases, simplification not required. So take note, the simplification is not required. So just differentiate. Do not simplify the answers that you're given. You just have to show what is supposed to be done on that differentiation. Then the rest, you leave it like that. All right, so that was question 2. Let's start with 2.21. Okay, let's see what you're given. That's 2.21 here. All right, so on 2.21, guys, we are given something like this. We are given 2.21. Y is equivalent to ln into cos to the exponent of 5, and we put 3x to the exponent of 4 like this. Okay, so that is the derivative. So if we are to check here, we are dealing with ln. Okay, ln, we want to find the derivative, but there is a ln. If it is ln f of x, this is a function with respect to x. The derivative of y with respect to x for ln is the first derivative with respect to x over f of x. So that is what you're supposed to have from ln. But now on this derivative, if we are to write our dy dx is equivalent to, our f of x is this expression which is affected by this whole expression, which is cos to the exponent of 5, 3x to this part. This is the one that is representing our f of x. So in this case, the part is saying we are supposed to find the derivative of that with respect to x. So how can you find the derivative of cot? So this is, we can just write it aside here. So how can you find the derivative of cot? Okay, this is cos, okay, not cos. This is cos to the exponent of 5, 3x to the exponent of 4. How are we going to find the derivative? So this now we are going to take it from our chain rule, but we are going to apply our chain rule in a direct manner. So how are we going to apply this in a direct manner? Okay, the first thing that you're going to do is to find the derivative. You find the derivative of the trig, which is of the exponent, that is this, with respect, like you're considering the exponent, which is 5. So if we drop this exponent, it's going to be 5. Of course, you subtract 1, which is to the exponent of 4, 3x to the exponent of 4. Whatever that you get from this part, you then find the derivative of this part that is inside the trig part that we are given here, okay, which is 3x to the exponent of 4. So what are you going to have from 3x to the exponent of 4? You multiply 4 times 3, that's 12x to the exponent, you subtract 1, which is 3. Then the last thing that you're going to do is to find the integral, the derivative in this case of the trig function that you're given, okay? So in this case, we know that if you are dealing with a cos, it is going to change into a negative sign. So whatever that you're going to have here is supposed to be multiplied to the negative. So you multiply to the negative of sign, and the trig, this part of algebra remains as it is. You're just finding the derivative of cos, which is negative sign. So this part is going to remain as it is, of 3x to the exponent of 4. All right, so actually, that is what we're going to have from this part of f of x. Remember, we say the derivative for ln is the first derivative, which is this first derivative that we got of 5 cos to the exponent of 4, 3x to the exponent of 4, then multiplied to 12. This is actually a multiplication that you are given in this case. So that's 12x to the exponent of 3 by negative sign by 3x to the exponent of 4 in this case. Okay, so everything that you're going to have here, you divide by f of x. So that means this f of x is going to remain as it is. That's cos to the exponent of 5 into 3x to the exponent of 4, like this. All right, so that's what you're going to have in this case, as we are given that the simplification is not required. Therefore, we can just leave our answer like that. What they need is to see the stages, or especially to know to that idea that you know these derivatives separately, then how to combine them, like what we just did from this one. Okay, so that was question 2.21. Then we move on to 2.22. Again, is the derivative without simplifying further. Just find the derivative as it is direct. That is what the question is actually asking us. So this is question 2.22. So remember that y was equivalent to 8x minus x to the exponent of 6 over x to the exponent of 3, and everything to the exponent of negative 5 over 4. All right, so in this case, actually, what can we do? What are we supposed to apply in order for us to find this derivative? Okay, so this is going to be from the chain rule, because here we can see that there is a complicated part, then an exponent. Okay, so from our chain rule that we have, which is actually referred to as the functional function, you can do it by side, because this here is another expression that you're having, or another term that you're having inside of another equation or another expression. All right, so that's dy dx. In this case, we're going to have dy dx is equal to, so from our chain, like I said, it's something that you're supposed to find its derivative by just looking at the number. You find the derivatives. That is what you can actually do by side. You can actually do that one by side. Okay. So what we're going to start with, let's start with the bracket, as it is the whole bracket, as it is including the exponent. So remember that you drop the exponent, then you subtract a 1 in this case. Okay, so if we are to drop this exponent that we are given, that was negative 5 over 4. So it's going to be negative 4 over 5, sorry. So that's negative 4 over 5 into the bracket as it is, which is 8x minus x to the exponent of 6 over x to the exponent of 3. Then we subtract negative 5 over 4, negative 1, which is going to give us something like negative 9 over 5. All right, we are done with this part of finding the derivative, but we are left with this part that is under the bracket, which is this whole expression. How is it going to be affected? So as you can see, this is one is actually a fraction that we are given. So that means we can apply the quotient rule, or you can choose maybe to divide each and every term by x to the exponent of 3, if it is like that, or you can just choose to apply your quotient rule. Applying our quotient rule, we are going to have this as our ux and this as our vx. So remember our formula. If you are actually dealing with the quotient rule, it's best to follow the formula as it is. That is finding the derivative of the, in this case, because you'll be given this as ux vx. So this is going to be u. So we are going to start with the ux in this case. Then we've got the derivative of vx. Okay, so minus, in this case, we are going to subtract. So now this time is going to be ux by the first derivative of vx over vx squared. So that's what you're going to have in this case. So that means we are supposed to apply this concept, guys. Let us apply this concept. So vx in this case is the denominator. So it is going to be multiplied to, all right, let's just use the one that I was already having here. So whatever that you're going to obtain, we are going to multiply back. Okay, so we're going to multiply. So we said this is Vx, which is x to the exponent of 3. So we've got x to the exponent of 3. Then by the first derivative of ux, which is the u, the first derivative of u, which is 8, and you drop the exponent there, which is going to be negative 6x to the exponent of 5. Okay, so that's what we have. Then we've got minus ux, so it's going to be minus ux, which is this bracket of 8x minus x to the exponent of 6 by vx, the first derivative, sorry, of v, which is v prime. So we're going to find the first derivative of x to the exponent of 3, which is 3x squared. All right. So everything that we have here is supposed to be affected by vx, by the square, that is vx squared. So the square here is x to the exponent of 3. So it's going to be x to the exponent of 3. Then we square this. This is what you're going to have as the resultant. So remember that the simplification, we are told that is not required. So there's no need for you to simplify further. Just leave your answer like that. So that was question 2.22. We're going to check another question, which is on 2.23. Again, the simplification is not required. So this is just, these typical questions is just by sight. By just looking at the question, you must know the stages to take. So we are given now that y is equivalent to the square root of, so we've got 1 plus the square root of 1 plus x squared, like this. Okay, so that is what you're going to have in this case. So as you can see, it's a complicated issue that actually we need to apply our chain rule. So actually it's the use of chain rule if you have to cross-check all these questions. So here you've got y, which can be written in a way or format that can allow us to apply the chain rule. Remember that square root means to the exponent of a half. So this is 1 plus, we also have a square root here. So it's going to be 1 plus x squared to the exponent of a half. But everything is affected by this outer square root, this square root which is outside of everything, which is to the exponent of half. So as you can see, it's a pretty question that you can actually use for chain rule, because we know that if you're given this, you're going to find the derivative when we are dealing with the half, which is the exponent, which is outside there. All right, which is out of the bracket. So this is going to be, you remember you drop the exponent, which is a half here. So this is a half. You drop the exponent, then you subtract 1. Okay, so that's the case. So that is going to be a half into 1 plus, we've got 1 plus x squared to the exponent of a half like this, which is, you can just write it under the square root, okay? So you can even write this under the square root. It's one and the same thing, okay? So from this part, we just find the derivative of the bracket, okay? Then you move on to find the derivative of what is inside of the bracket in this case, okay? So that was outer part. Then now move inside of the bracket. So this is the expression inside, which is 1 plus this whole part that we have here. So if you are to find the derivative of this, is going to be 1, which actually gives us a 0 because the derivative of 1 is just a 0, guys. Okay, then we move on now to this bracket. So how do you find the derivative of this bracket that you're given? In this case, you're given to find the derivative with respect to x of 1 plus x squared to the exponent of a half. All right, so take note, this is what we, so as you can see, this is back to that similar condition of the chain rule that we applied. So that means we are still back on our chain rule where we are going to multiply, start by the exponent, we multiply by the exponent, we subtract 1. So this is going to give us 1 over 2. It remains as it is, the bracket 1 plus x squared to the exponent of 1 over 2 minus 1, that is negative 1 over 2. All right, we are done with, by just looking at the exponent, that is what you're going to have. But whatever that you have here is supposed to be multiplied by the derivative of what is inside the bracket, which is 1, it's a 0, x squared, which is 2x. So this is going to be a product that you're going to have of 2x in this case. So simplification is not required. So therefore, just leave your answer like that. Okay, do not worry much, just leave your answer at that stage. On 2.3, we're now given calculate dy dx if y is equivalent to that whole expression or the whole fraction that we're given with the aid of logarithmic differentiation. Okay, so remember they were supposed to be helped or to work with the logarithms in this case in order for us to find this derivative. Okay, anyways, what do we have in this case? That's the question. Let's just write our question 2.3. So this is question 2.3, where we are given that our y in this case is equivalent to, that's 1 plus 1 over x to the exponent of x. All right, then we are supposed to apply the logarithms. So remember that if you are to apply the logarithms, you're supposed to introduce the logarithms for sides of the equation. In this case, it can be lean or it can be a log on both sides. Okay, so remember log and lean is one and the same thing, which means the laws of logarithms are the same laws that you apply even if you're dealing with these Napierian logarithms. So this is going to be lean of y is equivalent to, in this case, if you are to apply the lean, take note here, if I maybe to write it is stage by stage. This is lean like this. Okay, we've got lean, sorry. So this is going to be lean, okay, into 1 plus 1 over x. So from this consideration that we have, remember the exponent is still there. So we are going to apply the laws of logarithm, just the same laws, whereby if there is a number applying here as an exponent, you're going to multiply with that number there. So that is what you're going to have in this case. So the lean of y is equivalent to, if we are to drop this exponent, it is going to be x. All right, then we remain with the lean of this part. So it's x, and we've got lean 1 plus 1 over x like this. So this is what you're going to have at the end. If we are to simplify, then we can, there's a need for us to be collecting like terms for that consideration. It's very, very important for us to collect the like terms and substituting of the like terms into the equation. I mean, substitution, which is also important. So in this case, we have x lean of 1 plus 1 over x. what can we actually do in this case? Can we say our derivative is actually fine? No, because in this case, we just like dropping the exponent at this and that. Okay, so there's the concept. We can see on the left-hand side, we've got ln of y. But as we need the derivative with respect to x, we're now back to that implicit part whereby we can find the derivative with respect to y, of which ln is 1 over y. So it's 1 over y, but your answer, you multiply by dy dx, because you are supposed to find the derivative with respect to x. The same thing here is the derivative with respect to x. All right, so 1 over y dy dx is equivalent to what? If you are to check here on this side of the equation, these two are actually multiplying each other. So we've got a product of these two. So it's a product of x and ln in this case. That is what you're going to have at the end. So how are we going to apply now the rules of our calculations? It's the product rule actually that you're dealing with. Okay, so if you are working with the product rule, remember we've got two functions of ux multiplied to v of x. Okay, so if you are to start with the v of x, it's fine. Of u, you can start with the ux, then with the first derivative, then we add, now it's ux by, now it's the first derivative of ux, and we've got vx in this case. Okay. So if you are to check here, this is your ux and this is your vx. So you can substitute this into the formula. That's ux by the first derivative. So our ux in this case is this x that we see here. So it's going to be x. Then v prime, which is the first derivative of ln. Remember, to find the derivative of ln, it's if you are given ln like this, if first derivative of f of x, that is over f of x. That is what you're going to have in this case. So that means if we are to find the derivative of f of x, that is this part under the square root, under the ln, which is 1 plus 1 over x, of which 1 over x is same as x to the exponent of -1. So it's going to be 1 here plus x to the exponent of -1, where we can simplify by dropping the exponent, because this is actually a derivative. So it's going to be x to the exponent of -1. But the derivative, if we are to drop the exponent is -x, then we subtract 1 here, which is a -2. All right, so that means in this case, inside of this derivative, or for the ln that we are given, since is the first derivative over this, our first derivative is -x, so it is going to be like this, -x to the exponent of -2 over f of x. So our f of x is the function that we actually had before, which is 1 plus 1 over cos of x. All right, so from this stage, what can we do now? This is our product, then we are supposed to add. This time is the first derivative of u, which is x. We differentiate x, that is a 1, by vx, which means the vx is remaining as it is, which is, we've got ln. Everything here remains as it is, which is 1 plus 1 over x. All right, so I hope every information now is there. We've got all the information that we are supposed to use in this case. Okay, let's simplify where there is a need for us to simplify. So this is going to be 1 over y dy dx is equivalent to, here, is there anything that we can do, guys? Yes, we can simplify because there is a negative exponent here and we are multiplying. So it's going to be x by 1 over, to remove all the negative exponent. So it's going to be 1 over x squared into 1 plus 1 over x. So here we can actually reduce this, the x and the x squared, which is x. So that's why we end up with 1 over x in this case. So we are going to have 1 over x into 1 plus 1 over x, like that. All right, so that is what you're going to have at the end if you are to simplify. This is just a simplification. All right, not forgetting we had our negative, so there's a negative there. Then you've got plus ln, so this ln is going to remain as it is, which is 1 plus 1 over x. So that's what you're going to have at the end. All right, so if you are to check here, there is 1 over y. So as we need divide x, not 1 over y. So that means our divide x, if we are to multiply both sides by y here, that's automatically canceling the value of y. Okay, we do the same thing on this part. We multiply whatever that you are going to have, if it is that a condition, but we are multiplying by y, which is this one. Okay, so that's it. We are going to have y into negative. So instead of writing a negative first, you can even start with this part of ln. So it's going to be ln 1 plus 1 over x. Then we subtract 1 over x into 1 plus 1 over x. So this is going to be 1 plus 1 over x like this. All right, so that is what we have, but still our answer, if we are to check, it's in terms of y. Somewhere here, there is a y that we are given. So it's supposed to be with respect to x. So wherever there is y, we substitute the original y that we had. Y is equal to 1 plus 1 over x to the exponent of what? Of x. So this is what you're going to substitute with on your on our final answer here, which is dy dx is equivalent to, we substitute that y that we're given, which was 1 plus 1 over x. Okay, and it was to the exponent of x in this case. Okay, so that's what you're going to have from this part that you are given. We just have to substitute as it is. Then the remaining part, we just have to write also as it is, which is ln 1 plus 1 over x, in this case, minus 1 over x into x, that's not x, but that's 1 plus 1 over x. All right, so that's what you're going to have at the end. And in this case, we just have to leave our answer like this. You can simplify further. If there is a need to do that, then actually it's important. You just have to work it further. All right, on 2.4, we're now given the implicit function. So there is for you to differentiate the implicit function. Remember, an implicit function is the one that you can't make x the subject, or you cannot make y to be the subject. Those are typical questions. So we are given to calculate the y dx from this implicit function that we're given. So this is question 2.4, where we are given 25x squared plus 9y squared minus 70 x minus 30y like this plus 49 is equal to 0. So remember, if we are to find this derivative, okay, let's just remove this part, or let me just remove everything. Then now we just have to rewrite back this question. All right, so I'm going to rewrite back our question since we have removed everything here. So this is 2.41. We were given an equation as 25x squared plus 9y squared minus 70x minus 30y like this plus 49 is equal to 0. So remember, what you need is to find the derivative with respect to x of each and every part that you are given, which is the derivative with respect to x. So what are you going to have in this case at the end? If you are to multiply, that's 25 times 2, which is 50. Okay, so it's going to be 50x. We do the same thing here, the derivative with respect to x. We do not have x, so that's where you find the derivative of what you're given, then multiply by divide x. So it's 9 times 2, or 2 times 9, which is 18. So if you multiply this, that's the derivative, then you subtract 1, so it's going to be y like that. Okay, minus 70x. So here we are given minus 70x. What is the derivative of negative 70x? that is going to be negative 70. Okay, already we've got x there. Then for negative 30y in this case, we do not have x. So we're going to find the derivative with respect to y, which is negative 30. Then our answer is going to carry y x. On 49 is a constant, which is going to be is 0 in this case, and that one is equal to 0. So that's what you're going to have. So from this information that we are given here, is there any part that we can actually collect the terms together with the dy dx or whatever condition that you have in this case? Okay, so this was 18y, guys. Take note, this is y, so it's supposed to be dy dx. I hope someone saw that here. We do not have a dy dx. Okay, so I want you to combine these together. There's dy dx here, there's dy dx there. So this can be written as 18y dy dx minus 30, and this is going to be dy dx is equivalent to, if we have to check, if we have to correspond this, transpose the other numbers to the other side of the equation, we are going to minus 70 to the side is going to be a positive 70, so it's 70. 50x to the other side is going to be a negative 50x. All right, so from this part, you can see that these are like terms. You can actually subtract, or you can factor out dy dx, which is common. So by factoring out dy dx, we are remaining with 18y in this case, minus 30 is equivalent to 70 minus 50x. All right, so from this part to find dy dx, so therefore our dy dx is going to be, we divide now by this bracket, which is 70 minus 50x, everything over what we got there, which is 18 of y minus 30. Okay, so this is our dy dx, and every information that we actually needed in this case is there. There can be a consideration because you now have your answer where you can factorize because you've got common terms. That's another issue. But if you want to factorize further, this you could have written it as in the numerator 2 is common. So it's going to be 2 into 75 divided by 2, which is 35 minus 25x. Everything over here also 2 is common, which is going to be 9y minus 15. Okay, so we do not have any other part, or we can actually factor it as a 2, as a 6. But what is important is that these two can actually cancel the 2 and the 2. So that means our dy dx in this case is going to be this part that we are given as it is, or we just take the factorized part. But that's what you're going to have in this case. So we've got 35 minus 25 of x. So that is what we are given in this case. So it's going to be 25 of x. Okay, then we've got a there, which is actually the 2. Sorry, so the 2 and the 2 cancelled. We are remaining with 9 y minus 15. So it's just going to be over 9y minus 15. All right, is there anything that you can do with this case? There is nothing. You can factor out on top or if you want, but actually that's what you're going to, these are the typical questions and what you're supposed to use to attempt these typical ones. Okay, so that was your dy dx. Then determine the equation of the tangent to the graph at the point 2, 3. Okay, so now we need the equation of the tangent. So take note that if we are dealing with the equation of the tangent, so this is 2.42, all right? So we've got 2.42. In order for us to have the equation of it must be in the form of y is equal to mx plus c, where m in this case, that's your gradient. So we have to find the gradient, and we know that the gradient is simply taking from the first derivative with respect to x. That's where we have our values in this case, which is the gradient, which is the derivative. All right, so we calculated this before this dy dx. On this part here, we had to determine dy dx. So what are we going to have in this case is to substitute, because we are given a point, it must pass the point 2, 3. So this is the value of x and this is the value of y. So in place of x, we are going to substitute a 2. In place of y, we are going to substitute a 3. So we can test the values, the ones that we are given, if they do correspond. All right, so that's what we actually had from this question, which is actually on 2.42. And we need now to find the m, which is the gradient. So let's substitute. Y is equivalent, after substituting the points 2, 3 in place of x here, we are going to obtain this gradient expression of -5/4. Okay, so that's it, guys. I'm not going to use the calculator. I just want you to use the calculator direct. So this is your m, which is the gradient. So you can substitute into the equation. Y is equivalent to m. That's -5/4x plus c, where we can substitute that given point that was, which is at 2. That was at 2, 3. All right, so at that given point of 2, 3, you've got our x and y. So you can substitute the value of x and the value of y that we are given in this case, and our c is going to be 11/2. All right, so these are the values that you simply needed, that point, that you simply need to substitute into the equation. So therefore, our y is equal to mx, which is m, which is the gradient, that's -5/4x, plus c, which is 11/2. So that's what we actually had from this question, which was carrying 3 marks. But the whole of this question actually the derivatives, and we have to revise as much patience as we can, so that we prepare ourselves for the exams which are ahead of time. So that's what you had, guys, for Maths on African Motives, still on Maths N5. Also encourage you guys to be part of the membership or part of the members, so that you can have access to more classes that we have at Maths on African Motives. Till we meet again.